This video is going to cover a special version of factoring where we are factoring the difference of squares. You know that you're factoring the difference of squares because the numbers associated in the problem are perfect squares. So perfect squares would be like 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, and so on and so forth. So you know you are working with perfect squares. You are doing a difference of squares type of problem. The interesting thing about these factors is that there's no middle term here that has an x. Normally you see something like 3x squared plus 1x minus 7, right? And you have the x in the middle. But here you don't have that x in the middle. It's gone. So when it's missing, we know that the terms are going to need to cancel out that we're working with. So I'm going to show a few of these problems using factor squares to show you how they cancel out in the middle. And then I'm going to start working them without the factor square just by factoring them in your head and thinking it through by using the perfect squares that we have here. So our first one is x squared minus 49. And what I'm going to do is I'm going to set up my factor square. And I don't have any value in the center, meaning that it's going to add up to 0x. There's no x's in the middle. I do still have an x squared, and I do still have a number. And essentially what I'm going to do is figure out what numbers I can put here and here that will cancel out when I try to add them together. So it's a special pair of numbers that will cancel out. Of course, to get x squared, I multiplied x and x. And to get negative 49, I know it's the perfect square of 7. So I can get it by multiplying positive 7 and negative 7. So up here, I would get 7x. Down here, I would get negative 7x. And they would cancel each other out, adding up to 0x in the middle. So my factor of x squared minus 49, which is a difference of squares, is x minus 7 times x plus 7. Let's try another one. This one has y instead of x, but it's the same process. So there's nothing in the middle, meaning that my center values are going to add up to 0x. My y, 0y, because we're working with y's. Let me fix that. My y squared always goes in the top, and then my number always goes in the bottom. To get y squared, I multiplied y times y. And then I want the same number, different signs, so one's positive and one's negative, to multiply to negative 121. These numbers will cancel out. They are negative 11 and positive 11. Here I'll have y times negative 11, which is negative 11y. Here I'll have 11 times y, which is positive 11y. And negative and positive 11y, of course, cancel out. So my factor is going to be y plus 11 times y minus 11. Now, let's do one more, and we'll do this quickly. To get a squared, I multiplied a times a. To get negative 64 as a perfect square, I had to multiply negative 8 times positive 8. So I have negative 8 and positive 8, and that'll multiply to negative 64. I'll get 8a here, negative 8a here, and positive 8a here, and it adds up to 0a. It cancels out in the middle, so my factor is going to be a plus 8 times a minus 8. Now, we're doing something slightly different, but it's actually the same thing. We have a coefficient on our squared value that happens to also be a perfect square. So 9 is the perfect square of 3, right? So when I set this up, it's going to be the same situation. There's no x in the middle, so it's going to add up to 0x, so it will cancel out. And I need this to be 9x squared. Now, some of you might be thinking, oh, I could put 9x and 1x right here. 9x times 1x equals 9x squared. Well, that's good thinking, but we're trying to get our values that end up here and here to cancel out. And if they're different like this, 9x and 1x, it's going to be really hard to get them to cancel out. So instead of using different numbers, I want to use the same number. So I'm going to use 3x and 3x. And what will happen is when I multiply to negative 25, I can pick the same number with different signs, and those corner diagonal values will end up canceling out because negative 25, of course, is 5 squared. So I can use negative 5 and positive 5. Up here, I'll get negative 15x. Down here, I'll get 15x, and it cancels out exactly the same way as it did in the first 3 problems, because I intentionally chose 3x and 3x because they were the same value, and 5x and negative 5, 5 and negative 5 because they're the same value with different signs. So it would result in those 15s canceling each other out. So the factor of this is 3x plus 5 times 3x minus 5. Okay, let's do one more with the area method, and then we're going to start doing them in our head. We will get 16y squared on the top. Of course, it adds up to 0y because there's no y value in the middle. And our number here is negative 49. To get 16, we multiplied 4y times 4y. To get negative 49, we multiplied negative 7 times positive 7. Remember, we want the same sign, and then we want the same number, different signs. So we got the same sign with the 4y and the 4y, and then the same number, different signs with the 7 and the negative 7. So our 4 times our negative 7 is going to give us a negative 28, and we, of course, have a y with that. And then the 4 times the positive 7 is going to give us the positive 28y. And negative and positive 28y cancel out, so your factor would be 4y plus 7 times 4y minus 7. Okay, let's try to do this without the factor square. To get 4a squared, remember, we want the same number in our first spots. Of course, to get 4a squared, we had to multiply 2a times 2a. 2a times 2a is 4a squared. To get negative 21, we would do negative 11 times positive 11. That was just done without a factor square. Pretty cool. I'm going to prove to you that this works. We did it without the factor square, right? Now we can multiply these binomials together. So I'll do 2a times 2a, which is 4a squared. 2a times positive 11, which is positive 22a. Negative 11 times 2a, which is negative 22a. And negative 11 times positive 11, which is negative 121. And when we combine our two like terms that are right here, we get 4a squared minus 121. So that's how you check to make sure you did your factor correctly, but I know you're going to get all of these correct. Let's try 3 more. And we're doing this without the square. So to get 25m squared, I had to multiply 5m times 5m. To get negative 1, it's a perfect square, right? To get negative 1, I had to multiply negative 1 times positive 1. So that's one is a little bit tricky. People usually struggle with the ones for some reason. However, 1 times 1 is 1, and negative 1 times 1 is also negative 1. So you can work that out. 1 is a perfect square. Let's try the next one. To get 49p squared, I did 7p times 7p. To get negative 64, I did 8 and negative 8. Last one. To get 36t squared, I would do 6t times 6t. To get negative 81, I would do negative 9 times positive 9. And if you want to try multiplying those together to see if they work out, they should result in the original problem.